Welcome to aminacademy.com. In physics, regarding oscillations, let us do some solving problems. Look at this example. The motion of a particle executing simple harmonic motion is described by the displacement function x sub t equal a cos omega t plus phi. If the initial, that is time equals 0, the position of the particle is 1 centimeter and its initial velocity is omega centimeter per second. What are the amplitude and initial phase angle? The angular frequency of the particle is pi per centimeter, pi per second. If insert the cosine function, we choose the sine function to describe SHM, that is x equal to b sine omega t plus alpha. What are the amplitude and initial phase of the particle with the above initial conditions? Here, the SHM initial condition is given, that is t equal to 0 and particle is 1 centimeter and its initial velocity is given. Now let us start the problem here. A given displacement function is x sub t equal a cos omega t plus phi. Here apply the initial condition t equal to 0, initial condition t equal to 0, x sub 0, that is we are put 0 instead of t, we have a cos omega, that is t equals 0, x sub 0 is 1 centimeter. Also omega equal to pi centimeter square, that is we are using x sub t equal to 1 centimeter equal a cos pi, that is omega is pi, time is 0 plus phi. Here this cos phi, a cos phi, that is here pi into 0 is 0, that is a cos phi is 1. Let it be equation 2 here. Also differentiating the equation 1. Now equation 1 is x sub t is a cos omega t. Differentiating this is equal dx by dt, that is v, d by dt of xt, that is differentiating this one is cos t is minus sine omega t plus phi into omega t's differentiation is omega, that come here, that is minus a omega sine omega t. When t equals 0, substituting t equals 0, it becomes omega equal minus a omega sine, also omega equal to pi given, pi into 0 plus phi, which gives omega equal to minus a omega sine phi, that is omega equal minus a omega sine phi, because we are substituting here 0 here. Therefore from this omega is cut both sides and becomes 1. Therefore we have a sine phi equal minus 1, that we have here. Omega equal to minus a sine, that is a sine phi equal to minus 1. Now look at this one, equation is 4. Squaring the equation 2 and 4 and adding. Equation 2 gives a cos phi equal to 1, then a sine phi equal to 1. Squaring and adding, that is a square cos square plus a square sine square, that is 1 square plus 1 square. So having square root of 2, a equal to square root of 2, because we know that here a square sine squared phi plus cos squared phi equal 2. This is 1. Therefore a square equal to root 2. A square root 2, that is amplitude is root 2. Now dividing these two equations, that is a sine phi equal to minus 1, a cos phi equal to 1. Therefore here a cut, therefore sine by cos is tan phi equal minus 1, therefore phi equal to tan inverse of minus 1 equal to 3 pi by 4. Therefore, the phase angle is 3 pi by 4. We got. Now, next part. Instead of using, if instead of the cosine function, you are using sine function, that is for SHM, is x equal to b sine omega t plus alpha. What are the amplitude and initial phase of angle with the above initial conditions? The same conditions you have to follow. Look at here. Here, instead of cos, we are using sine function for SHM. X equal to b sine omega t plus alpha. Then differentiate this one. Dx by dt is v. That is v b sine omega t plus alpha. Differentiation is b omega cos omega t plus alpha. Putting t equals 0, using x equal to 1, the initial conditions given. Therefore, v equal to omega. Get 1, that is 1 is given for velocity. B equal to sine omega into 0 plus alpha, which is equal to sine alpha. B equal to 1 equal to b sine alpha. Then and omega equal to b omega cos omega into 0 plus alpha, that is b cos alpha equal to 1. So we have b sin alpha equal to 1 as well as b cos alpha equal to 1. Squaring and adding, we have b square sin square alpha plus b square cos square alpha equal to 1 square plus 1 square. Therefore, b equal to square root of 2. Then tan alpha is division of equation 5 and 4, that is equal tan alpha equal to 1. Because look at here, b sin alpha equal to 1, b cos alpha equal to 1. Therefore, tan alpha equal to 1. From that, alpha equal to pi by 4 or 5 pi by 4. So, we have phase angle is 5 pi by 4. So, we got next question. Spring balance has a scale that reads from 0 to 50 kg. The length of the scale is 20 centimeter. The body is suspended from this balance when displaced and released. Oscillates with a period of 0.6 centimeters seconds. What is the weight of the body? Look at here. Here, M mass of the body suspended is 50 kg. That means the scale reads from 0 to 50. Therefore, mass is 50. It can withstand. The length of the scale, that is y equal to 20 centimeter, which is equal to 0.2 meter. And the body is suspended from the balance. When displaced and released, oscillates with a period is 0.6. Time period t equal to 0.6 second. It oscillates. What is the weight of the body? Now we know that force equal Ky, means from that we have to find force equal to mass into gravity equal Ky. From this, K equal mg over y, mass is 50, 9.8 over y is 0.2. The simplification gives then K equal 2450 Newton meter. That K value got it. Now we know that time period of oscillation is 2 pi root of m by k. That is 2 pi root of mass is 50 over 2450, which gives squaring both sides, that is t square equal 2 pi whole square is 4 pi square and square root will go 50 over 2450, which gives then from this we know mass. Here this mass we cannot get with 50. Mass we have to keep it because its range is 50, but mass we have to keep it m. So from this T square equal 4 pi square m by k. From this m equal k t square over 4 pi square. K equal the t, that time period is given 0.6, 0.6, that is k value is 0.6, t squared is, no, k is 2460, 2460, k value is t value is 0.6 into 0.6 over 4 pi square, so which gives m. So after simplification, m is 22.3 kg. Now mg, force mg is 22.3 m into 9.8 Newton, which gives 218.5 Newton. That much force. That means we need, what is the weight of the body? Weight of the body is 218 Newton. Weight of the body is 218.5 Newton. Next question. A spring having with a spring constant 1200 Newton per meter is mounted on a horizontal table as shown in the figure. A mass 3 kg is attached to the free end of the spring. The mass is then pulled sideways to the distance of 2 centimeter and released. 2 centimeter and released, and it's vibrate. Determine the frequency of the oscillation, maximum acceleration of the mass, the maximum speed of that mass. Look at here. Here K, spring constant, is given 1200 Newton per meter. Mass is given 3 kg. Acceleration is 2 centimeter, which is equal. No, amplitude is 20 centimeter. 2 centimeter, which is equal 0.02 meter. Here the frequency formula is V equal to 1 by T is 1 by 2 pi, which is equal to 1 by 2 pi into square root of k by m. For SHM, frequency is this. So we are using the values 1 by 2 into 3.14 for pi, and k is 1200 and m is 3. So by solving this, use 3.2 centimeter per centimeter, that is a frequency. Acceleration is, formula is omega square y, that is omega square y is k by m into y. Omega equal to k by m, and omega square equal to k by m, and y. Acceleration will be the maximum when y is maximum, that is y equal to amplitude. So we are using acceleration maximum is ka, instead of y we are using a by m, that is 1200 into 0.02 by 3, mass is 3, so it gives 8 meter per second square. Maximum speed of maximum speed of mass will be when it's passing through the mean position. At mean position for SHM, velocity is maximum at mean position, therefore V max equal a omega, a into square root of k by m. A is amplitude is 0.02. Here the pulling distance is 0.2, not amplitude. Pulling distance is 2 centimeter, which is equal to 0.04 meter. 0.02 omega is square root of k by m. K is 1200 by 3, which is equal to 0.4 meter per second square. We have done. Please subscribe our YouTube channel.